You got a haircut. That's good. Okay, grab one of the sheets up here. Okay, I'm thinking you had enough time. Okay? So, what did you think? How would you try to do it? What did it seem similar to? Rachel?
Well, I would take the moment at C, and that's coming out in some direction. And then I just take that and I dot it with the unit vector of CD.
Right. So in order to find the moment about line CD, it's the moment about C dotted with the unit vector of D. What's another way of describing the moment about CD? If you are dotting the moment about C with the unit vector of CD, what are you finding? What's the relationship between the moment along CD versus C? The moment on C. What's that word that begins with a C, which you learned about before we did statics? Component. You are finding the component of C along line CD. Okay, so let me say that again. You are finding the component of the moment about C along line CD. You're finding the moment about point C that is along line CD. So isn't this true if I put a forces in there instead of moments? Sometimes it's hard to visualize spinning. Whenever you have a hard time visualizing spinning in moments, everybody with me? If you ever have a hard time visualizing spinning in moments, make believe it's a force. Because a moment is a vector, a force is a vector. You are very comfortable with saying, if I wanted to find the component of the force C in the line of CD, you would do this. You would say force CD is the component of the force along line CD is equal to the force of C times unit vector. So if you ever have a feeling like, boy, I can't really understand it, think, okay, well, yeah, it's a moment, it's a spin, but it's the same rationale that you would use in forces. So if you do this then, how do you calculate it? So calculate the math, and what do you get for the moment about CD? So the moment of C is negative 180I plus 36J minus 150K dotted to the 150K dotted with the unit vector of CD. So who needs more practice seeing things in 3D? Raise your hand. Who needs more practice? Okay, Maria, you're going to do it. Going from C to D. How much are you going in the X?
100.
100. Positive or negative?
Positive.
Look, take a look. C to D, right? I always put my, you guys, I always put my arrow on here so I don't get confused. And the positive x-axis is coming out. So going from C to D is positive or negative? Negative. So negative 100I. How about J? Here's the Y. Going from C to D, does it go in the Y? No, so it's 0. What about in the Z?
120.
Right, and it's positive, right? And that is E, right? So did I just do this correctly?
No.
What is wrong here? What did I put?
You put R.
I put the R vector, right? So what do I need to make sure I do? 100 squared plus 120 squared. And what do you get then for your answer? Yeah,
For the unit vector C going along D, shouldn't the x component of it be positive since we're going up
okay,
towards
say it again?
Shouldn't the unit vector be positive since we're going up towards D?
Okay, so let's see. So do you mean the 100 or the 120?
The 100.
Okay, so the 100, I'm looking at the x first. Here's the x-axis, right? So if I had my rolling ball, going from C to D, I'm going along this line, and I'm going back. So it's got to be a negative,
Alright.
okay? Yes, you're right that we're going up, but up is the z-axis, not the x-axis.
Joanne?
Thanks for asking a question. Chris?
Also, the force is in Newton meters, and then we have our.
Yeah, I know. I'm figuring that you guys are so comfortable going back and forth from millimeters to meters.
Okay,
So,
just pointing it out.
yeah, and so I'm not being consistent, and I should be, but I'm thinking that that's something you should be comfortable with. What did you get for the unit vector? What did you get for the unit vector?
0.6402i.
0 point?
6402i. And
Did more than, who got that? 6425 negative?
Yeah.
Yeah, okay, what else? No J. Okay, and the K is?
0.7682.
7682, positive, right? K, no units, right? Did somebody else get 7682?
I got
Yeah.
6402i.
You got 6402?
02. Yeah.
Somebody else? This is where the checks come in handy, right?
Yeah. It's pretty small.
Okay. Okay, what did you get for the moment about CD? Came out to be a weird answer. 0. Should have been 0. It's a scalar, so you should have gotten 0. Okay, wait, I see people still looking at this. Question, Daniel.
I don't know, why do you have RCF there? Are we solving?
No, I'm just writing all our information
Oh,
down
okay.
for the future.
Okay.
Okay, now we're back here. Okay? So you should have gotten 0. Now, it could be that since you're playing back and forth with the millimeters and meters, you might be getting a weird number. Okay? How many people got 0? Okay. So, what does that mean? Take a look at the picture. The force is going down towards us to the right, and line CD is going away from us up. Right? If we got a moment about line CD of 0, what does that mean of the relationship between the force and the line?
90 degrees.
They're either parallel, right? Because if two lines are parallel, right? If the force is parallel to this line, can this force create a moment about this line? No. What's the other situation? Not 90 degrees, but if they intersect. If this force intersects this line, can it create a moment about it? No. This force has to be off the line, right, for it to create a spin. Here, creates a spin, right? But if they intersect, it cannot create a spin, right? Lonnie, put your hand up. If I'm pushing on her line, I can't create a moment. The only way I could create a moment is if I come off this way or come off this way. So looking at the picture, do you think they're parallel or they intersect? Should take a look. They intersect. If they were parallel, they would have to have the same unit vector. Is that right?
Yeah.
They would have to have the same unit vector because the unit vector controls the direction. And CD has no y component, but AB has a y component. If the force was here, if this was B and A was in the upper point of the box right there, they may be parallel. But this to me looks like they can't be parallel, because they're more like this. Okay? So, let's back up on what we did.
So you're saying when you project the force into the XC plane, you're gonna get a line there?
Yeah, and I actually drew it.
What's the plane
I drew it to scale. I drew it to scale, and I found out that, and I did the math too, and I found out this is where they intersect, so they do intersect. But you don't have to do that. We're doing statics, not math. Not too much math. We don't have to find intersections of lines. So let's back up a little. And we have a lot of lights on. I don't think we need all these lights. Is that good? Okay, so what did we do? We were given, is everybody with me? We were given a force. We knew the magnitude of the force. We knew the direction from the drawing. We calculated what the vector is. So we know what the x, y, and z components are. Then we were given this point, and we found the moment about this point due to this force, and we did it two different ways. And we represented it. Then what we did is we took that moment about the tail of the force, and we dotted it with the unit vector to get this value. You want a shortcut?
Yeah.
Yeah.
Okay. So, and you guys had asked me about determinants before. That's why I wrote this. This was for the next step. If I want to find the moment about a line, I know that it's R cross F dotted with the unit vector. Give me the subscripts. If the moment is, originally it was about C, right? Force was from A to B. What was R? From C to A, right? Because it's the tail of the force. Dotted the unit vector of CD. Take a look at this. You do a 3 by 3 matrix. And instead of putting I, J, and K up here, you now put the X, the Y, the Z, the R. I'll move in a second for you guys on the right of me. So when you want to find a moment about a line, if they don't add, I'll wait till you copy this first. So in this problem, first we found the moment about point C. Then we found the moment about the line. Well, let's say that you are only interested in finding about the moment about the line. You couldn't care less what the moment about the point is. You could go directly to this and find the moment about a line by just knowing these three vectors, and then you put them in like this, and then you have a 3 by 3 matrix, right? A 3 by 3 matrix that every spot in here is a numerical value, so you just find the determinant on your calculator. So by now you guys should be really comfortable using your calculator for matrices. I don't think on the test you had a 3 by 3 at all. You didn't have 3 equations, 3 unknowns, right? You only had 2 unknowns. You still could have done it by plugging and substituting things, but you really now need to make sure that you know it. Daniel, question.
I was gonna say that gives you a vector, right? So,
It is not going to give you a vector. It shouldn't, right? Because look, there's a dot product in here. And there's no I, J, and K. They're all numbers. You're going to get a
I
scalar.
see.
And if you plug in all these numbers, you should get a 0, because we already found out that it's 0. Okay, good question. Is it nice to have shortcuts too?
Mm-hmm.
Right? So, just checking on your understanding. If I need to find the moment about a line, no, that's not a good question. All right, everybody good? Okay, so let's look at the syllabus for the homework. So today is what? 26, plus 7? That must be March. What's a week from today? March 2nd or 3rd? March.
Like 7?
No.
I think it's
Oh, it must be the 22nd.
Fifth. 5.
5.
2016.
How many problems?
2006.
How many problems? 5, no sweat. Okay, so if you're trying to find the moment about a line, you could do it all vectorially, right? You just find, you're getting more practice in looking at things in 3D. You're going to find out what the R vector is, what the force vector is, what the unit vector is. So you're going to get more comfortable with 3D again, finding components too, and you just put them in the matrix and you find them. If you need more practice doing 3D right-hand rule, but you're going to get more practice another way, you can do it, do it in a two-step process where first you find the moment about the line. I would just go straight to doing it this way. Okay? So you find the R vector, the F vector, and the E vector, and you do a determinant, and you're done.